Since the war against Russia began, Ukraine owned the skies with cheap, relentless drones striking deep into enemy territory. But in late 2024, Russia unleashed a new kind of drone, one immune to jamming, untouchable. Ukrainian forces were left blind. Their defenses crumbled as these drones rained down hell, ignoring every countermeasure. In weeks, over 1,000 attacks shredded their lines. With 5 Russian soldiers for every 1 Ukrainian, drones were Ukraine's equalizer. Now, that edge is gone. The balance of power flipped overnight. Russia wasn't just catching up. By 2025, it's winning the drone war. And the bitterest twist: Ukraine had built this pivotal technology years ago, then tossed it aside as expensive and obsolete. Now, it's scrambling to find an answer to the unstoppable drones they helped design. For years, Ukrainian forces had an answer to Russian drone attacks: electronic warfare and jamming signals, forcing enemy UAVs to crash before they could strike. That advantage is gone. In late summer 2024, a new type of drone appeared on the battlefield. First in isolated incidents, then in growing waves. Drones that could not be jammed, that ignored every known countermeasure. At first, their existence seemed impossible. Then, Ukrainian units started getting hit by them, again and again. These new Russian FPV drones don't rely on radio signals. They don't transmit. They don't respond to interference. Instead, they're physically tethered to their operators by thin, nearly invisible fiber optic cables stretching up to 10 kilometers across the battlefield. There is no signal to jam, no frequency to block. The only way to stop them is by physically severing the cable, an impossible task when they're darting between buildings, skimming tree lines, and slamming into Ukrainian positions at speeds exceeding 150 kilometers per hour. The irony is staggering. Modern warfare has spent decades moving toward wireless, autonomous, AI-driven weapons, severing connections between operator and machine. Now, Russia has reached back into the past, back to wires, and somehow this step backward has outmaneuvered the most advanced counter-drone technology Ukraine possesses. They are not the first to do it. There are other cases of wired weapons, like the wire-guided American TOW or the Ukrainian Struna P, but no one expected the same principle to be used in drone warfare. More importantly, no one expected it to work this well. On August 13, 2024, in Kursk Oblast, Russian forces deployed one of these drones in combat for the first time. The Prince Vandal of Novgorod, manufactured by the Ushkoynik Scientific and Industrial Center, executed its mission with chilling precision. By the end of September, it had been used nearly 1,000 times with an astonishingly low failure rate. 1 or 2 crashes per 100 launches. There was no test phase. Russia had already scaled production and integrated these drones into the battlefield. The war had changed, and Ukraine was caught unprepared, though it didn't have to be this way. 2 years earlier, Ukrainian engineers had demonstrated fiber optic drone technology to the military. They flew a prototype, proving it worked. They warned that electronic warfare alone would not be enough, that Russia would eventually develop countermeasures. But the officials in charge dismissed it. Fiber optic control was too expensive, too impractical. At the time, a 10-kilometer spool of fiber optic cable cost $3,000, nearly 10 times the price of a standard FPV drone. Ukraine, locked in a war of attrition, could not afford to take risks on expensive, unproven technology. The project was shelved. Russia did not make the same mistake. By March 2024, when Ukraine finally fielded its own fiber optic drone, the Banderik Lenta, Russia had already deployed entire squadrons. The battlefield no longer belonged to Ukraine's jammers and disruptors. Now, every Ukrainian position was a target, every defensive line vulnerable to drones that could not be stopped. Electronic warfare, the strategy Ukraine had invested so heavily in, specifically to counter Russian drones, had been rendered useless. The search for countermeasures began in desperation. Engineers immediately tested infrared sensors, acoustic tracking, and experimental detection systems, but nothing seemed to produce good enough results for mass deployment. Physical defenses were also proposed: net launchers, overhead wire barriers, shotguns loaded with buckshot. The problem isn't just finding a solution, it's time. Russian drones are already striking targets daily, and every delay allows them to refine the technology further. In the last months, The war has been slipping from the Ukrainian military at an accelerated rate. The advent of fiber optic drones has only increased the severity of the situation. Drone technology, previously a focus of Ukrainian tactics, is used widely by both sides, with Russia's deeper pockets quickly gaining an advantage in the unmanned aerial vehicle confrontation. In eastern Ukraine, near Pokrovsk, the war has become a battle between Russian infantry and Ukrainian explosive drones. After nearly 3 years of conflict, Ukraine faces a severe shortage of soldiers. Many of its troops are older, newly conscripted, and lack battle experience. The increasing reliance on drones has transformed the battlefield. Large armored vehicles are rarely used near the front, as they are easily targeted by drones. Instead, Russian infantry advances on foot in small groups to evade drone detection. However, drones alone cannot fully stop Russian progress. Ukrainian officers acknowledge that without more soldiers, they cannot hold the front indefinitely. A Ukrainian battalion commander south of Pokrovsk noted that drones disrupt enemy attacks but cannot replace ground forces. His unit has already retreated about a mile. The same scenario plays out across the Eastern Front, where undermanned Ukrainian brigades are under constant pressure. Moscow recently captured Velika Novosilka and is advancing toward Chasiv Yar. In some rural areas, Ukrainian drone pilots defend entire lines almost by themselves. A drone battalion from Ukraine's 60th Mechanized Brigade, operating near Terny, intercepts Russian troops using explosive drones. The unit's commander, Monin, directs drone strikes remotely, eliminating Russian soldiers before they reach Ukrainian infantry positions. A year ago, his team launched 15 first-person view drones on a busy day. Now, with Ukraine producing 200,000 drones a month, his battalion deploys at least 60 daily. Thermal vision surveillance drones make it easier to detect Russian movements at night. Despite these advancements, Russia continues to make slow progress. Russian forces around Terny have taken over most of the village, suffering over 1,000 casualties in the process. However, their seemingly unlimited manpower allows them to press forward. Poor weather conditions and electronic jamming occasionally down Ukrainian drones, giving Russian forces an opportunity to attack. A Ukrainian medic in Pokrovsk reported that 70% of casualties in the area are caused by drone strikes, mostly Russia's new fiber-optic guided drones that cannot be jammed, leaving soldiers to try to shoot them down. The war in Ukraine is a drone war now more than ever, but if the Ukrainians don't find a way to stop the fiber-optic drones, it's a war they will not be able to fight for long. As the situation turned bleak for Ukraine, a massive breakthrough took place in early 2025. Magyar Bird's drone unit has recently developed a countermeasure for the fiber-optic drones. Using mobile radar systems, they can now detect incoming FPV drones several kilometers away. The moment a Russian drone is identified, Ukrainian operators launch their own FPV drones to intercept and destroy it mid-air. The hunter becomes the hunted. Robert Brovdy, known as Magyar, commander of the unit, recently released footage of the new defense system in action. In the video, a Russian fiber-optic drone is spotted, tracked, and eliminated before reaching its target. The wreckage reveals its bulky fiber-optic spool, a weakness that Ukraine is now exploiting. These spools, essential for guiding the drone, make them heavier and less agile, giving Ukrainian FPV drones the speed advantage in direct aerial combat. Though Magyar did not disclose the exact radar system in use, military analysts believe it operates in the Ku band, a frequency range optimized for tracking low-altitude, slow-moving objects. However, these radars have limitations. Their short range, just a few miles, means they must be positioned dangerously close to the front lines. The plan is to deploy them in a dense network every 2 to 4 kilometers, creating an overlapping detection zone that leaves Russian drones nowhere to hide. What started as an improvised Ukrainian tactic in 2022, when a consumer-grade Mavic drone was filmed knocking a Russian UAV out of the air, has evolved into a full-scale doctrine. But this new defense comes with risks. Mobile radars, while effective, emit signals that can be detected and targeted. Russian forces are already known to use anti-radiation missiles and drone strikes to destroy Ukrainian radar installations. Mounting the radars on mobile vehicles improves survivability, but given the 600-mile front line, scaling this defense across the entire battlefield will be a logistical challenge. Despite these hurdles, Ukraine's ability to counter Russian fiber-optic drones marks a crucial turning point. The war of drones has entered a new phase. one where survival depends not only on how fast one can strike, but how well one can defend.